Hello there, my name is Peter and I've been using different iterations of YOLO algorithm for the last give or take 5 years. Today I have something quite special for you, a feature that is so new that it's not even officially released yet, and I'm talking about instance segmentation using YOLOv5 framework. In past, YOLO architecture has inspired instance segmentation models, like for example YOLAct or YOLAct++, but the instance segmentation functionality was never officially part of any major YOLO framework up until quite recently. YOLOv5 is mostly known for being very easy to train object detection models, so let's take a look if it's equally simple to train instance segmentation one. Roboflow has actually created a quite detailed tutorial on how to train such a model. Link to that particular blog post will be in the description below. And we will go for each step of that tutorial and try to train our own. So let's get our hands dirty, and we will start as usual by creating our own Google Colab environment. For those who are quite new to the computer vision world, Google Colab is this interactive place where you can train deep neural networks on GPUs quite cheaply, or in many cases for free. The only thing that you need is Google account to sign in. We are ready to go, so let's start. First thing that we need to do is connect our Google Colab that is running in our browser into Python environment and GPU instance. So we just need to confirm that we are not a robot and solve some small puzzle for Google, which is quite funny because they are using those annotated images to train their deep learning models. And we should be ready to go. Yeah, GPU has been loaded. So the first thing that we'll do is run the first cell over here. We just need to confirm that we want to run that cell. Google is letting us know that this particular notebook is not authored by the Google team themselves. It's fine, it's community driven. And what is happening here is we are actually installing all the dependencies of YOLOv5 project in that Python environment. Most importantly, PyTorch. Looks like our Python environment is ready. All required dependencies have been installed. But before we start the actual training, it is usually a good practice to check whether or not everything works properly. Typically, how we do that is by running a pre-trained model on some example images. So I already downloaded the pre-trained weights from Ultralytics server just to save it a little bit of time. And I will be running those two cells over here. The first one is downloading the example image. The second one is actually loading one of those models into the memory and running it over the image. And in a few seconds, we should see a result. Yeah, looks like we are ready to start the actual training. To train custom model, you need dataset. Within our tutorial, we used American Sign Language dataset that is accessible at Roboflow Universe. So let me just use that opportunity to quickly show you how easy it is to interact with those datasets, and most importantly, use them in combination with like any major computer vision framework right now to train your own object detection and image segmentation models. So we follow the link from the tutorial, and immediately we see the list of classes that were used to annotate the images. You can even go into the images and examine every individual annotation if we want to, or select some of those images and clone them into our own separate dataset. We'll not do it, however, today. We are going back to Overview, click the Download button at the very top, and select the format of the annotations that you would like to use for the export. Given the fact that we are training YOLOv5 instance segmentation model, I will just select YOLOv5 PyTorch and click Continue. Right away, we get ready to use snippet of the code that we just copy and paste. Keep in mind that the snippet contains API key, so I will just go ahead and do it for us. So we are back in Google Colab. The download of the dataset has been completed, I replaced my API key with the placeholder string. Keep in mind that you should always keep your API key private and don't share it with anybody. And right now we can start the actual training. So to train the segmentation model, it is important that we are using a different script than we are using usually to train object detection. It is located under segmentation subdirectory, and here we have a different train py script. So we will use that particular script to train the model inside Google Colab. We will set the number of epochs to 100, and the data location will be set to dataset.location. Our Python package allows you to download the dataset, but also allows you to evaluate where the dataset is located, so you can later on integrate it with any framework. Model training can be actually a time-consuming process, and depending on the size of a dataset, as well as the power of the machine that you use for training, can take between few minutes or even few days. So try to be patient. On the other hand, the size of a dataset, as well as the variety of the images in it, can be actually a positive factor when it comes to something called model robustness. In other words, how well is your model behaving in real-life scenarios? One of the great ways to improve that is to use augmentation techniques that are offered within Roboflow Universe. So over here in our tutorial, with just few clicks, we apply operations like flipping, rotating, and blurring images to increase the number of images in a dataset by 3 times. It is definitely a good technique that you can try if you have problems with some specific edge cases. And after a few hours of training, we are finally ready to test our model. So within the final step, we will validate our model using the script provided by the YOLOv5 team. So this script will load the model into memory and run it on validation set and compare the result obtained by the model with the annotations provided within the validation set. So it's pretty useful because it allows you to compare every class separately. Yeah. So we can use metrics like MAP to assess whether or not our model is performing equally good for every class, or are there any outliers that would require an additional training? Yeah, so we can clearly see that, for example, letter T is such outlier. Yeah, compared to letter Z, our MAP matrix is definitely lower. So in real life scenario, that would mean that we would put additional time and effort to add maybe more images containing that specific letter, or maybe better augmentation techniques, or maybe to balance the data set somehow to achieve better results for that specific class. Other thing that we can do is to basically visualize the detections that we are obtaining. And this is done in the cell that is running currently. So for example, we are picking the random image from validation data set and just running detection and visualizing that. So it looks pretty fine. Yeah, and that's it. I hope that you had a great time watching that video, learned something, and I hope to see you guys next time. Bye.